How's it going? Hope you're having a good day today. Welcome, welcome. Welcome, welcome, welcome. Uh, cool. All right, we're live. Hello, everybody. Welcome back into the stream. Hope you're having a good day today. Today we're gonna be jumping back into programming and continuing on with building projects and writing some code. We're gonna be writing some Python code today. Continuing on with our stonks. Last time we worked on this project, or not really project, mainly kind of just like fun programming. It's not like we're building to some sort of end goal. We're kind of just building things that we find fun every once in a while and adding on to a base repository project. So whatever you would call that. Um, Last time we were in here, we modeled what it would look like for you to simulate investing X amount of money in Y ticker symbol. Um, and then 1 year or the first year after IPO date, and you're able to model how long it would take and what your investment net value would be after, or total value would be each sequential year there forward. And it's a pretty cool graph. We can go over that and demo it if you guys would like. If you guys weren't here for that stream. But today we're going to be shifting gears, similar realm. I'm going to be pulling option data this time around. And I'm going to see if I can I had a previous project idea about a year ago that I never finished. Mainly because I don't think I was as good of a programmer. So we're going to come back to that and try to finish it this time around. I'm not sure why I was struggling with it last time. I think it just seemed daunting and maybe I didn't want to do it, but it doesn't really seem that difficult now, a year later. We're going to be three-dimensionally modeling a surface plot of options data. I am not exactly sure the parameters of the axes of this plot. We can get into that when we get there, but I think it should be pretty cool. Think of like a three-dimensional plot that looks like a mountain, and what that mountain tells you is actually like heat intensity for various parameters for options data in the stock market, right? So, kind of cool. Anywho, let's go ahead and see if we can get started with this. I think what we did last time is we obviously need to refactor. We just copied this out and into here. Basically, it's like a script. And so we need to just make this a script and then import the script and then write it. So I'm just kind of being lazy right now. But we'll just do it in here just to be safe here, and then we'll do so like get options data.py. Okay, so what we're gonna do is let's import y finance, and then let's import daytime and pandas. Okay, we'll import the actual datetime object. Okay, so let's see what we can do here. Okay. So let's establish some dummy information here. So let's just say ticker is a string. Let's say it's Microsoft. Let's go ahead and so ticker is a string Microsoft. We're going to call yfinance.the ticker object. Ooh. And we're gonna get Microsoft, right? I'm going to say let me print the stock. Okay, so stock has a bunch of methods. Let's do stock dot. Does it have an options? It does. It says a utility options has a options chain for a given date. Okay. Let's give a date of. Now, is this a datetime object? And time zone, it's got to be a daytime. If I remember right. So we'll do daytime.today.date. Okay, and then we'll insert into here the today. And then time zone. I'm not going to give that. Let's see what happens here. Okay. Options chain today, expiration date can be found. Oh, it already expired. Is there like a tomorrow? Can you can I do like today plus 5? Can you add, is the dunder add built in for the date? I wonder. Never tried that before. Yeah, you can't. I think what you have to do is add a time delta though. Let's just add a oh. It's a time delta, right? And days, let's say it's 1. So let's add a time delta to today. I think that's how you do it. You have to add a time delta object. Damn. 625, okay. Why can't I find an option for tomorrow? It'll give me this though. It should. What? Oh, it's a string. That's so stupid. Okay, let's just, we have a stock. I think what you can do is you can access the expirations date of the stock, right? I think you can do that. Stock dot expirations, right? And this is going to give you a tuple, right? And then we can index into expirations queue, the next expiration date. Let's just do that instead. Okay, so it's a dictionary. I thought it was a list. Ugh. How did I do it last time? Yo, what's up, AJ? How you doing, my boy? What are you working on? Let's do stock dot options dot. Let me look up the Wi-Fi in stocks. Options. Get capital gains, get info. No. I thought that there was an expirations. Data options execute calls. Data options change. Data options. Oh, data options indexes. Okay, the data options. Let me print this thing real quick. Okay, there's the tuple I was talking about. Okay, so now we can just do expirations, and then we'll do expirations goes into here, index of 0. There we go. Okay, there we got it. Working on getting a iOS game ready for actual release. Oh, that's right. I forgot to check that out on Discord. You have to remind me to do that. I need to do that for you. My bad, dude. Sorry, I move into my new place next week. So after next week, hopefully a little bit of hecticness dies down and we can start doing the multi-stream again and really settle into it. And I can, get into a place where I actually, enjoy stream. I got the cat box over there, so it stinks in here. I don't really like being in here for that long. It's not that comfortable, so I can't really stream for long periods of time. It's very cramped. I just, we've been kind of winging it for the past couple of months, and I really appreciate you guys being so bearing with me here. But, okay, let's see here. Okay, so we got a data frame. Okay, cool. I need to get better at pandas. Polymarket advertising scandal. I did not. What is that about, AJ? E-ink. What's e-ink? What's going on, Punisher? Okay. The Punisher. Wait. Ah, jeez. Okay. So that gives us a data frame, right? And it gives you, and these are our headings, or our columns, right? We have 73 rows by 14 columns. Underlying language, U.S. region, U.S. equity. Okay. So what I want to do is I want to extract out. What we're going to do is we're just going to focus on the calls for right now. And we're going to extract out the oh, I think it returns as a tuple. What do we print? We printed stock.option. Okay, so yeah, I think this returns us calls and puts. I think, right? And then we can print calls. Dang, actually it doesn't. I thought it did. Maybe it prints it returns a tuple. Dang. I guess I'm wrong. Returns and options. Okay. And then we can have options object. Options dot calls. There we go. And then we can print options dot calls. And there we go. There's our singular data frame. Perfect. So we'll just capture this. Okay, so we have calls here, which is this data frame, which is just this property of this options object. All right, so this returns. Just from my memory. Then making tens of thousands. E-ink is a paper-like screen that uses low power and is easy on the eyes because it's not backlit. E-ink is the paper-like screen. Is it like a product? I'm not really sure what you're talking about. Okay. So what we're gonna do. Oh, sorry, I don't need to do this. So what we're gonna do is we want to get the. So we have this data frame, but I want to get a list of all the calls for the current. How should I do it? So we want to get all the calls. So we have to what we want to do is we want to get out all of the calls. So each row is a what is each row? Sorry, I forgot. Let's just do this. It's not a function. And we want to have a file. We have all of our calls. So here's our index, symbol, date, strike, last price, the bid, the ask, change, percent change, volume, open interest, open implied volatility, in the money, regular, USD. Okay. So what we want to do. Interesting, so percent change is here. It's these values. Negative 4%, negative 75% change. Negative 90% change. 300% change. Is there an extension for like pretty printing seamlessly display and edit CSVs? Edit CSVs with table like UI. 2.3 million. It's their guy here. Okay, let's see. This might be helpful for us. Let's see here. Okay. Sweet. That's good. Okay, so implied volatility. 1, 0, then back to 1. Okay, cool. So we could just choose a metric. Open interest, volume, implied volatility. Maybe even percent change. And so what we want to do is on the x-axis, that's what we'll plot on the z-axis, is that kind of defining that like statistical parameter. On the x and the y-axis, or in the depth and the x-axis, I guess. So that'd be the z and the x, I guess. So that'd be the y is the one. That'd be the amplitude axis is the statistical value. So then in the x-axis we would have like strike price, right? And then in the y, into the depth of the screen, well, that's kind of, you would need a bunch of additional options, right? So that's where you would, okay, so let's think about this. The x-axis is strike price. Well, one pane in the depth is just 1 day. So yeah, got you. So we would need to compute this in a loop. Okay, I get it. Okay, so what we need to do is we have to get, let's just break this down. We need to get the list of percent change or some metric. So let's say this is what we're gonna do. Okay, this is what we're gonna do. So we're gonna have some sort of metric. So I'm just gonna put this out front here. So metric, or say stat metric. Stat metrics is equal to, we'll just say this is a tuple, and it's going to be, you can have implied volatility, you can have volume, and you can have applied volatility, volume, open interest, and maybe percent change. Well, I guess we would need to keep the consistent with what it's returning here. So it's giving us, it's in camel case. Be percent change, volume, open interest, implied volatility. Open interest. Like this. Okay. So we'll start with those three for now. And what we need to do is for this single, right, we're doing this for a singular option, right? Well, and then we'll expand out from there. We're getting calls for this option, for this expiration, right? I'm going to comment out this, and we'll move this down. Okay. So what we're gonna do is we have these data frame of calls, and we want to extract out the implied volatility, the implied volatility, the volume, or the stat metric, right? So then what we're gonna do, I guess we'll just make a stat. Is going to be stat metrics index. So we'll just get the implied volatility. So we have calls, key. Oh, this one I'm bad at pandas. So to index into, we have to do dot log. What is this, a data frame? Yeah. So we'll go calls dot locate. Now let me look up pandas data frame dot locate. Primary label base, but also it must be used with a Boolean array. Locate Viper. So this is rows. So we want to get like a column. So how do you like, well, I guess we'll just do how to extract a whole column from pandas data frame. Square brackets, column name to extract a single column series. Multiple columns past that. Index of, okay, so it calls index of column. And so this is going to be the stat, I guess, and then we'll print this. Okay. So now we have that whole column. So now I want to do to list. It's not going to give it to me unless I do this. There we go. Okay, cool. That works. Can I like type define this as a like ed.data frame? So yes, okay, so I can get those. So it knows it's a data frame at least. Okay, so now we have the amplitude data, right? We have it in a list. I guess we'll say dot to numpy to get it in a numpy. Oh, we're not printing. We'll print the amplitude data. There we go. Okay, so now we have that numpy array of amplitude data. Now what we're going to do is get the we're going to get the strike prices. So it'd be strikes is equal to calls index key of strike price, is it? It's just strike. Okay, and then we'll also do to numpy there. Okay, and then let's print strikes. Make sure that's working. Nice. So, and then that strikes. And then I guess what we're going to have to do is we're going to do our options expirations. That's going to be our y-axis or our depth axis, and we already have those extracted, right? And so what we're going to have to do is, because this gives us the strikes by amplitude data for this specific option, right? And so for every option, we're going to get strikes and amplitude data and plot those all together in a three-dimensional plot, right? So in order to format that data, we would have to, because it has to be the same, not necessarily. That dimension doesn't have to be the same. It doesn't have to be a straight cube. There's a lot of strikes out there. It can be like a rectangle, right? because you have this, if you print the length of amplitude data, and then if you print length of amplitude data equal to length of strikes, right, this Boolean should return true. They're the same length because you have an amplitude you have amplitude in correlation with each strike. And so we can print those, and that value is true. And so, but the length of options, right, this should not be the same. Three and 75. 3 is the length of options. Oh, I'm sorry. Expirations. 21. Right, so I think that's okay though. I think just our amplitude, our x and y have to be equal. And then we just stack those days together, right? Okay, so what we're going to do is we're going to have data, or we're going to have results up here, right? Right? And it's going to be a dictionary. And what we're going to do is we're going to say for expiration date in expirations, right? Right, this is a tuple, these are strings. We're going to get all of this information for each, right, expiration date. But we're going to have to get this here. Right? So we have expiration date, and we're going to insert that into here. So for every expiration date and expirations, we're going to get the options data for that expiration date, get the calls for that options data. We're then going to get the amplitude data and the strikes for those calls, and then we have that information. And so what we're going to do is we're going to save into results key of the expiration date, right, is going to be equal to a tuple of amplitude data and strikes, right? And that's how we're going to build this data object. So then if we just go ahead and print out the results, which should remain inside main, apologies, right? We should get options data and calls for each strike. Yeah. Now, what I'm going to do is actually I'm going to reformat this and label these in a dictionary called amplitude, right? Amplitude is going to be the amplitude data, and then, and just separate this out so it's easy to read here. And the strikes, because we'll put it's like kind of makes more sense to put the strikes first. because that data usually comes first in your mind. Put the strikes here. So we'll wrap this data object kind of like this JSON nested dictionaries. And now we can print results here. And we should get something pretty nice. Cool, so now we have strike, and we have amplitude for each. Now, the thing is are the strikes the same? 330, 270, no, 280. $280 through $560 for these strike prices. $270. Huh. Doesn't look like we have equal length values. Interesting. So this goes 270. Okay, for this one, strike starts at 345 to 370 to 490 to 525. I'm gonna take my data. This is what AI is good for. Take my data here and plug it into here and say, gathering 3-dimensional data for stock option where amp is a statistical value in the data. Why do these tickers or the strikes, which was going to be my x-axis, have differing values? Because option chains are not sampled on uniform strike grid. I thought they were. Well, maybe not. Your data structure is really expiration date, 1 dimension, strike, 2nd dimension, amplitude, 3rd dimension. Your measured statistic. The issue is that each expiration is a different set of available strikes. For example, the 26 has strikes 270 through 255. Ooh. $270 through 255, including many 250 increments. Oh, that's right, because, you know. Because the further out the money, the larger space. Irregular mesh options that you report independently. It's going to cheat crazy. Interpolate amplitudes. Okay, so maybe we'll do this. Let's do this. We wouldn't want to because this will interpolate. Create a common strike grid. right? So this will do increments of 5 in the range of 200 to 805, 801. Or to 800, but we don't really want to moneyness. The x-axis can be relative distance from the stock price rather than the absolute strike. That's also produces much cleaner surfaces. Oh, they do strike over stock price? Okay, interesting. Interesting. So the option 3, normalizing strike by dividing strike by stock price or taking a logarithmic of strike over stock price, how does this then uniformly distribute the stock price dimension for into an applicable range? You're just normalizing by the stock price, but that doesn't actually sync the actual values for that axis. Normalizing strike and a moneyness changes the meaning of that. Suppose the stock is trading at $400. Strike is 300. Strike price. Strike over spot. Over the spot price is 0.75, blah, blah, blah. But there's still discrete points. The real advantage appears comparing different. Imagine today. A month later. Same account location at the money. Using moneyness, they're identical. Consider example. Notice money and values are much closer to each other. What practitioners typically do is convert strikes to moneyness or log moneyness. Do a linear space and to relate each expiration onto that grid. Now every expiration has amplitudes at exactly the same x values. K over S. So I think I'm confused on, right, I'm building a three-dimensional surface where amplitude is a statistic like implied volatility or volume. The x-axis is strike price or some sort of consistent metric across what would be then the depth axis, which would be, or the z-axis, which would be each expiration date for said strike prices normalization. I think the source of confusion is that you're thinking in terms of 3D surface requiring a complete rectangular grid, but mathematically it doesn't. So let's redefine the strike or moneyness, expiration date, amplitude. Each observation is a point. Strike sets. That's right. This perfectly valid point, Cloud. The issue arises when you try to create a smooth surface mesh. For each expiration date, you have a curve, amplitude versus strike. So for June 26th, strike points to an amplitude as one curve. Stack all those curves behind one another. You get this for every strike curve. Volatility surface. So I get that 400, 350 strike means 350. Makes you go strike. Makes you go strike over the spot price, or now your x-axis is this, which means 20% below the spot price at the money. Okay, so let's go ahead and, so instead of calculating the strikes, right, we have strikes, a list of strikes, and we want to compute on the list of strikes the strike price over the spot price of the option of the stock, right? So we have stock, we have spot price equal to stock dot price, stock dot what is get price, maybe? What would it be? Let's look up price. So it's in just fast info or in history. Okay. So stock.fast info. And then we want to do key of, or what would this be? We want to, before we do this, we just print this. Run it. These are our keys. Last price. Last price. Okay. So then what we're going to do is we have this, and then we want to make a amplitude data is equal to a list of or is a so how would you perform, maybe can you perform like a lambda expression on a NumPy all values? Perform an expression on a NumPy array for all values without looping over each value. Most efficient way to perform this is to vectorize operations or broadcast which applies element-wise without Python loops. Okay, so you can actually just perform the operation on it. Okay, beautiful. So we'll just divide each value in amplitude data by the spot price, and then that will be our not our amplitude data, our, what am I doing? our strikes, I guess, and then we'll do this divided by spot price, right? And then this will be normalized, or we'll just say moneyness, like in the moneyness, right? Spot price, or say, we'll say strike price normalized by spot price, which determines how in the money. Okay. Or quote moneyness. So this would be moneyness, and then this would be moneyness. And so let's print out our results here. Amplitude, moneyness is array. 5.0, right, they're much closer. So the thing is so, okay, cool. Or wait, maybe we wanted to do the, it's okay that the x dimension is not one. Yes, in fact, option surface is completely normal with the raw inputs are not completely uniform. Much most perfectly important thing is the coordinate values are known. And then, okay, just connects these points all together to create a curve. Okay, beautiful. I think that's the script. So what we're gonna do is we have a little bit more time here. I'm having fun. We're less than an hour in. We're cooking. What we're gonna do is let's go ahead and I'm going to write in a route here. I'm going to just make this route. I'm going to make a home route just so I can reuse that, and then I'll change the other one. And then what else do we need? I think it's fine. Okay, cool. So what I want to do here, you're back, AJ, what's up? Is I'm going to take my main function here. Now I know I need to figure out a way to incorporate the scripts, but I don't want to do that today. So we're just going to copy it into here, and then I'll refactor it out later. No, it's not about the best practice, but sue me. Okay. So you're given a ticker here and a stat metric. And we're just going to remove the stat metric for right now, and just do this. Actually, we'll keep the stat metric and put it here. Right. Okay. And then what we're going to do here is just return results. Okay. Beautiful. Beautiful. Cool. So now what we're gonna do is let's just wire up UV-corn main app -- reload. Okay. And then what I'm gonna do is I'm actually gonna remove in here. I'm just gonna take this. I'm just gonna take it and just hard code it into here for right now. Just to get something working, and then I'll remove stuff later. I don't use this either, so I don't actually need this. Okay. Nice. And so if we internal server error. Cannot convert dictionary sequence element 0 to sequence type error vars elements update attribute. Data vars. Hey, how's it going? Kamu, welcome. Appreciate you coming back in. What's going on here? Oh, so let's just return, maybe not a pandas, or we don't need a NumPy array, but rather just a list. Let's list this. Oh, whoops. Okay, cool. Nice. So if I go, let's pre-print this. 7172, perfect. That's really good. That's exactly what we wanted. Okay, we're doing a stock option volatilities or stock option statistical metric surface. I think it's going to be pretty cool. So what we're going to do is let's go ahead and we're serving that to our front end now. So let's go into our client now, our source app. This is our app right now. All right, it's kind of this all this one page. What I need to do is create a page. Pages. This is going to be this is going to be 10x, or we'll say inception investment page. Inception investment. Okay, that's this page here. So we're going to take this, return it. Our main takes an app. So we're gonna just delete this. Or maybe, hold on. No. Okay, and then we're going to from import inception investment. Oops. App inception investment gets wrapped in. How did we do it in Labra? Let's see. App has use state, sidebar. I'm gonna kind of take this main dashboard thing we have. I'm going to throw this here. So then we're going to create a folder called components. And then I'm going to just rip from Labrat those components that we had made already. Copy. Paste. Oh, shoot. So we'll go into source, paste, components. There we go. And so then what we'll do is we have our app here, which has all that information. Good. If I go to here, cd into a new thing, cd into client, cd in, or do npm /app.jsx does not exist. So we're gonna kill this, run it one more time. How do you install React Router, John? Is it? Okay. Cool. So now we should be able to run this. Okay, so then we need to npm dash save. That's right. Okay, so now if we run dev, okay, cool. So we just need to do, get rid of this. Okay. So then routes. This is going to be to, we want to do pages inception investment. So we're going to do import inception investment and put that here. Right. And then we're going to have a new route to our new page, which is going to be our options surface. And then that's going to be here is options surface. Right. And we want to have a page options surface .jsx. Let's come over here. Probably have, I don't really want to write this page, so this fetches investment from localhost ticker investment. Okay, so what we need to do next is, right now we're routing heat map, given data ticker, cool. There's our actual page, format currency function. So what's our issue here? It worked. Okay, let's inspect. Option surface is not defined. Beautiful. So we're going to do export default function options surface. Open this up. Return. Alright, let's just return a fragment. So in our layout, there we go. No routes match the location home. Okay. So if I go to, what we're doing is we're pinging. So in inception investment, what we're doing is we're pinging this fetch here. So that's what we need to do as well. So let's grab, I guess let's just grab this whole thing. And we can retrofit it to what we need. So we're going to be an option surface here. Be up here, right there. Delete this. Okay. So we have ticker. This is just going to send us data, so I guess that's fine. Investment, we don't need this. Set data, okay, loading state, cool. Async, true, set loading. Fetch this API, 800. So in our main function, we are going to fetch okay, so this is going to be slash what's going on here? Getting lost. Hold up. Okay, so in options surface, we're going to fetch 800 slash options surface. Actually, we'll keep this and we'll do ticker and then for the options surface script, you need to pass the ticker and the statistical metric. Right? And I'm going to get rid of this stat. Take the stat metrics out, put that there. Actually, we'll take the stat metric. you actually don't do anything with the step metric right now. So we'll just take the ticker symbol. Okay? We'll take the ticker symbol. How about? That's what we'll do. I need a privacy policy for HTE App Store. Legalese, dude, honestly, man, like, breaking down, like, those legal documents is, this might sound cringe, and I know, but just use AI. That's what those tedious, like, annoying things are good for. Like, give it one pass over in your own work, like, give it one good read on your own, and then do, like, a summary and see how much, so at least you know if it was, like, if it's fibbing or things like that. But, for, like, HOA documents and things like that, finding niche rules about parking or contracts about, your lease contracts. Like, AI's pretty good at finding those, like, little things that you need to find in them. Okay, so we have that. This is going to be get home. This is def options surface. Right, this is going to be get options surface. So here we'll run this function, pulling from the ticker. So this will be get inception invest. Right, and then we can uncover all of this. Uncover all of this. Inception investment, right? Okay, so then if we okay, so we need to go to our app here. We're just ripping our old code here that we use. So let's go to our layout. This is going to be stonks. Mike stonks. Stonk. Stonks. Okay. And then we have a sidebar option via these routes. So if we go to, this goes to equipment type. Okay, so we are in a sidebar, we have stonks. So this will be main map. Okay, so here. Okay, got you. So this is where we do it. So in sidebar, we're going to import nav item /home goes to dashboard, RX dashboard, beautiful. Config. We'll say feature nav. feature nav, we're gonna go to inception, investment, and we're gonna do that here. Okay, and then FA funny bill. FA clock. Okay, let's copy this down. We're going to include option surface here. And add it here. This is really turning into full stack dev, I guess. No, I can usually read it, but I can't write it on my own. Stonky? Stonky donkey? I like that. Stonky donkey. Big stonky. We'll have to do it. We'll change it over. Okay. This is features. Okay, so then if we go sidebar component, adding boundary config nav, it's feature nav, right? Okay. Routes, match location, equipment type. No. Okay. And app.jsx. No. And 68. Oh yeah, because we were, okay, cool. So option surface, we're gonna so now this should work. No? Oh shoot. .404 not found ticker symbols. Is server still running? Get ticker Apple for investment max. .404 not found. Okay, so it's running our API. Here. Get slash this not found. Okay, so wait, it's running. There we go. Full stack, baby. Full stack. Full stack. Phase up. All right, cool. So that's the Inception investment page, right, from last time, if you remember. So if you put $1,000 into Microsoft, right, this is what it would look like from Inception. So from inception, it would go 2,000, 2,000, 4,000, 6,000. If you invested it this year versus this year, right? This is if each year you started later and later. So 1 year in Microsoft just hasn't done any, like, no way this is right. Wow, really? No way. Microsoft really? Oh no, no, we're not getting all the data. Oh, there it all is. Let's download it. Okay, so the 2000s. The zoom on here is pretty brutal, right? It's hard to kind of read. Some of these stocks go way back. $1,000 in a Microsoft really doesn't. Well, actually, it does. Here in 2012, I have it download as an image here, and it becomes a. What is this file type? PNG, right? So 2000 in a Microsoft back in 2000, you would this needs to be negative 0.4x return. That's a bug. So if it's in the red, it needs to be negative 1.1. So if you put lately, right, Microsoft's an interesting name. 2025. It's just doing, like, this is like really interesting. Like this barrenness for like Microsoft's early investments, like last time we had a barren landscape like this with some red trickled in was like around here. Did these investments pay off over time? Like, yeah, definitely. 12, 14, 16, 19, 20x at one point, right? Maybe let's make it a little bit more like visual. This isn't what we just built. This is what we built last time. I'm getting sidetracked here. So here, right, 10,000 in a micro. I just bumped up the value, so it's just a little bit easier to see, or kind of right. So 10,000 in a Microsoft back in inception. If you bought it the first year after IPO, right, it would have taken you under 10 years to 10x your money. Oh no, sorry, you 10x it here. You get to 50x here, right? So I think what would be like if we computed stats next for like an additional feature for this page would be like if you like metrics like average like per year like a breakdown by year time to 10x and then like an average time to 10x time to 50x like by year by average like in total those metrics would be interesting, right? So look at this. Like, if you bought Microsoft here, dude, you've been just like This can't be right. Is this right? This cannot be right. Really? In 2010? 10,000 in a Microsoft? Loss. You're just pretty much still at break even here. Still underwater though, the whole for 5 years. You 2x your money in after like almost 10 years. Like 9 years you 2x your money. The S&P 2x's your money every 7 years. Right? So like we would want to maybe compute like on average how long to 2x your money and then compare that to the S&P average of every 7 years, right? Or is it every 14 years? I can't remember. I associate the spectrum yellow, red, yellow, green to be bad. I didn't know. I didn't want to use like purple. Yellow just means like gold, like you're getting into like you're golden. Red's the only indicator for bad. This is not in production. No, this is just in my on my repo. This is like we're building out like kind of like a cool stock. It's like statistic page. Okay, so like interesting. Let's take a peek at what should we do next? Let's take a peek at let's take a peek at Burke B. All right, Burke B. Berkshire Hathaway. Berkshire Hathaway. Let's see here. $10,000 into Berkshire Hathaway in almost more years than not. You lose, you win. It's about break even, and then here it's starting to really pick up. This streak, you put $10,000 in at the start of the year, you gain amount at 1 point pretty consistently. Finally, a bad year. Okay, that's the next thing we're gonna do is before we send this data, we're gonna compute some metrics. Maybe we'll do it on the front end, so it's faster. But honestly, whatever. We might. I don't know, because we're computing all this in Python. I mean, we could just pull requests and do it all in JavaScript. Like that's totally an option too. And then it'd be all be fast. It'd be no API, no nothing. But so we want to do like time to double, time to 10x per year, like in a year breakdown. Time to double, time to 10x, and then like an average overall. Like, right? So it'd be like on a row breakdown of time to double your money, time to 10x your money, time to 50x your money, and then an overall average as well. That's what we'll do next for that. Okay, so let's go back to our options surface here. So what we built today, so we got sidetracked. Maybe we'll just have to make it to like real. I don't know. Like I will have to figure out a better color scheme than AJ. I'm all ears. Done stress testing. Um, no, I don't know. It's not. I didn't even write my. I didn't even write my function here async. Inception investment is just synchronous, so it's definitely not prod ready right now. So don't even try AJ. But for our options surface, we are going to send the data to the front end here. Use state is not defined options surface here. Okay, this is our function. So we're going to get this option surface for the given ticker symbol. Okay. Okay. So what we're gonna do is we have that, which gives ticker, JSON way set data, nice. False, cool. You give a ticker, and this is gonna be a drop down of options, right? So this will be, well, we're not gonna have these options, so I'm just going to this initial investment div I'm going to comment out right now. So let's go to the option service, inspect. We're going to get rid of the heat map. This. Okay. Fetch data. Set ticker there. Option surface. A 3D 3 view model of options. Okay, and then where is this error at? Option surface. Where's this error at? On line 2, const set ticker. Apple. Okay. Like if I put up a Go server to try to DDoS your server in 3 hours, no, not good. Not good. Consider adding error boundary. So app.jsx option surface here. Uncaught reference error. Use state is not defined. Oh, I'm dumb. Okay, option surface here. Okay, so then in our, this is going to be the button that we're going to do is going to say where's the button? Import button dark from dot component. Nothing. Pause. Okay. We want the button dark. And what we're going to do is on the button here, we're going to do button dark. Import button dark from /components. Components. /button dark.jsx. Text nav on click. Just gotta give it a text. What the heck? Failed to resolve import. Components button some source/pages option surface. /components button dark. I'm gonna take this. I'm not messing around with this. Throw that in there. Find me my bug. Button dark. Import button dark. Components. Okay. Nice. Now we'll go to option investment and we'll do the same thing here. Button dark will take over the button here. And then the text is going to be this. Okay, so then button dark text is for this one. Option surface is going to be generate the surface. Generating. Okay. We're going to fetch the data via the ticker given. And then in our main, ticker goes in and gets given here. Accept. Okay. So option surface is going to return, if we inspect this, we open this up, go source network, refresh. Okay, cool. Now if I run this, there it is. There's our response. Okay. Great. So now what we need to do is build the surface right here with a plot. And I think I'm going to do that next time. This was a really good stream. Let's go ahead and push our stuff. Add options. Script. Cool. All right, you guys. Thanks so much for being here with me today. This is a really cool project, right? Where we have, you can, right now you're able to, for any stock symbol, let's look up like, I don't know, Gap. What happens if you were to invest $10,000 into Gap since inception? Wow, holy cow! What an investment in the 81. Holy cow! In 5 years, you would have. Holy cow! The Gap went nuts back in the 80s. Oh my god. 10K to 200K in 5 years. Holy crap. 20x return in 5 years on the Gap. You hit 50x return in 10 years. You hit 130, so that's over 50x plus in less than 10 years. 10 years you hit 132% on the stock, not on an option, on the stock. Oh my gosh. I mean, here again, look at this. Look at here. 1, 2, 3, 4, 5 years to 10x. You 2x in 1 year. You 5x'd in 2 years. The Gap went crazy in the 80s. Now the Gap is dead money. I actually called the play on the Gap a couple of months back, and I was right. I made money. I don't know if any of you guys played that with me. I think I called this run on the Gap. I got to go look back at my Discord, but I think it was right here. I said that we were going to, that this was a buy, this dip right here, and we ran. Or maybe it was, yeah, I think so. And then I stopped watching it since April. Yeah, I'm pretty sure it was here. I said this dip was the buy. I did buy it. I sold at, I think like 26. I sold like right here. Yeah, it looks like, yeah, the Gap is dead money here. So it's just, I mean, here was a pretty good year. Holy, yeah, 2x return in 3 years. Right. This is also going off a buy at the beginning of the year. Let's look up Netflix. That's what you wanted to see, AJ? All right, Netflix. Netflix in 2003, if If you invested 10,000, you 4x, you almost 5x the first year. You drop back down to 2.5. So that's the thing, is you got to be able to stomach these swings. You go up to 50K from 10K, you're feeling pretty damn good. You drop down to 22. Oh, gut check. Gut check, right? Right back up to 47 the next year. Imagine you sold this year. Yeah, you made 2x your original investment. The next year you're right back up where you were. And then, 5 years from there you're at 30x, right? The power of holding, a solid company, a solid growth company, if it works out, is really insane with the stock market, right? But you got to be able to hold for some of these things we're seeing is 3 to 5 years. But this is like if you bought Netflix at IPO in 2003 or 2004, 2002 was at IPO, so this would be 2003 is the year after IPO. Um, Interesting. So when was like another year in the past? Not like the like. I mean, you see patterns in stocks, right? So like the algorithms and patterns, but like this. So years that you start off red back here. If you were to buy on these years, if you were to like, okay, you're down. So let's say not, you wouldn't be able to like know in hindsight that, oh, if I bought here, I would be down four, right? I'd be down 60%. I only have like zero point 0.4 left, right? 4K. But like if we use this, this data here, these instances, these occurrences as indicators for, okay, what if we bought here when we see here? Like we see this happening and we buy this year. What happens? Right? So like here we see it happen kind of like these two red years back to back. Like of different intensities but similar stories. Right? Obviously there's bigger macro data involved, 2010, this is 2020 COVID area, right? Netflix, booming off of COVID. Did it boom off COVID? I can't remember. Right? But if you were to buy here, you're not even 2x your money yet. I mean, you might actually use 2x it here because if you buy at 8K, then boom. But at that value. So maybe you 2x your money in 3 years if you follow the same principles. It's not a bad gig, but that's just if you're relying on this kind of goofy historical data analysis. All right, cool. So next time we'll work on the options surface. We have it all set up now, right? We have the ability. So if I just go here to my network tab and I generate this surface, it's right, it's fetching it right now. There it is, boom. And here's all of our surface data. We just need to take this data and plot it. And this is going to be a three-dimensional plot that we should be able to rotate around and view kind of like a surface on. And like, like neural networks and stuff kind of model surfaces, why kind of a similar kind of visual. Not the same mathematical concept, but same kind of visual-ish kind of thing. So just for this dimensional shape, this tensor shape. So anyways, I appreciate you guys being here and hanging out with me for today. This is a 2-hour stream where we wrote a back-end script for generating data to gather options data and feature engineer it in a way that represents a plottable surface by normalizing the strike prices against the actual spot price of the stock in order to get more in the moneyness indications rather than sporadic strike prices for options. This is kind of a difficult concept if like you've never traded options contracts or stocks in general. Stocks are one thing, but options and derivative contracts are a whole nother ball game in stocks, right? There's all these different financial products that these institutions offer, and options being one of them. And they're based off of calculus and math, and these like Greek values that determine the movements of the underlying pricings and things like that. But it's a kind of a lot of interesting touch and feel for experience with options. But it just goes to show you, though, that experience and understanding in certain areas can apply if you know programming, because you can use programming to take that data and visually model it, manipulate it, statistically evaluate it, and do many different things like we're doing here. So, you're bridging gaps between two kind of different fields to create kind of cool new visualizations and products. So thanks so much for being here. Appreciate you guys joining me. You guys can join the Discord link down below. Also, make a Codecrafters account using my partner link. So you can make a free account and practice building projects. This was a great little stream we did today. I had a lot of fun. Next time, what we'll do is we will build the options surface page. So the options surface page right here, we got the data, and then this will be a 3D visualization of that surface page. Build a product around it. I don't know. If we got like a bunch of different a bunch of fun stock modeling in different features, would that be something people would be interested in paying for for access to for fun? I don't know. I think it'd be kind of cool. Anyways, thanks so much for being here, and I'll see you guys next time. This is more of a full stack stream. I might have to change the title to it because it stayed dead in here. But if I put this title as full stack, it might have went crazy. Let me actually go. I'm gonna go do it right now. I'm gonna go change the title of the stream to full stack, and I guarantee you, it will actually get more views. I got a comment on my last video of me reading C Programming: A Modern Approach, and the guy said I started a new book every day. I was on chapter 18 of that book. I've been reading that book for a year. It's bro, what? All right. Full stack project from scratch. Stock options modeling, graphing, quant analysis. There we go. I guarantee you that will get better engagement. Maybe we should stay on for 1 second. I do think that there is a lot of opportunity for bridging the what's the word, institutional educational gap that option contracts have for retail investors. A lot of people would probably be interested in option contracts. Not that it's for everybody, right? But people might be interested in it, but they just don't really want to learn it because it's a lot of information. I myself don't know all the ins and outs of all these Greeks and whatnot. I know enough to get me by and make informed decisions and make some plays, but nothing to I know how to wheel and I know some different strategies, but I don't really get into those iron condor strategies and those more vertical spreads and things like this. I kind of keep it pretty simple. The thing that it is dangerous, AJ. That's the thing, right? Is that you don't actually own any underlying asset. You buy the right to own the underlying asset, and that's what people don't really understand. In the English is very, very specific. You don't own the asset. You own the right to own the asset. What does that mean? Well, you have an option. Now, options become more familiar if you are in like corporate America and are granted like RSUs or like targeted date options for stocks to funds and things like that. Part of your compensation packages. It's pretty popular for like more like managers and up level. I've never been granted one myself, or my company is not like that. We're not a booming tech company, but it's just the right to own. You don't actually own the option unless you own the actual asset unless you exercise the option. Now you can exercise the option, um, at any point, but you can exercise that even in the negative, right? So you could potentially. So let's say that your stock now the company, if you have company options, you're not going to be able to exercise early because it's part of some like limitations written in the underlying fine print saying you can't exercise until X date, or above a certain amount of price, right? So, but with you could shoot yourself in the foot normally, right? But so let's say you have a stock trading at $100. I think that the stock is going to go up big. I buy the $200 option, right? But there's a little bit of an additional feature that comes with buying options is you have to pick a strike price. We said $200, like the bet price that we think, right? Um, Now, whether it goes above $200 or whatever, there's certain types of value with option contracts. There's intrinsic and extrinsic value. So we'll talk about that later. But um, you, so you buy the strike price, and then you buy time, right? And the more time you buy, right, an expiration date, a future date, the more expensive typically the contract is, as you have more safety cushion for recovery or whatnot. But with options, is you have things like theta, which is one of these Greek characters that we mentioned, and you have things like implied volatility, which is a statistical metric of like basically how what the market thinks the anticipated move of the underlying stock, right? So implied volatility, if you have 100% implied volatility, well, people are anticipating that this move is going to be quite large, right? That the future move is large. It's kind of like coming up to earnings date. Implied volatility rises as if people are bullish on the stock because an earnings date could project the stock higher, and people are already baking that into the price of these contracts, and so the price of the contract grows. It's kind of like a popularity tax almost, but not really. It's more math based than that. Now it's people are predicting, it's baking in the almost, it's hard to describe. um, but the thing that gets impacted by applied volatility is you get like this thing called theta decay, or IV crush is what people like to call it. And as that implied volatility is really high, it also can come down really fast as that move did not happen in the anticipated allotted time that was suggested, right? Or was anticipated. So let's say that on the Monday you think the stock's going to go really high. Well, on the Thursday the stock never actually moved, and it's Thursday now, and you have even less time. You have one day till expiration, so the odds or the statistical likelihood that it'll actually reach that high price is even less now, and so it impacts a lot of other value in the contract, and you get just kind of exponentially decayed in value, right? That's where and then you don't actually own any assets, so the stock option goes to literal $0 in value. All of your money is lost, right? There's no ownership unless you exercise. And so exercising, like what we mentioned before, is where you actually convert the option contract into the physical asset shares. So in each contract is worth 100 shares. Um, And so you would then exchange the contract for the value. Now, if the actual share price, if you have the $200 option and the stock is at 205 and you exercise, well, you are immediately in a green, right? Because you exercise that. You have the right to own that stock at $200. Even if it's at 205, someone sold you that option contract for the right to own it at 200, and you have the right to exercise that contract. So if you exercise the contract, then they have to sell you the stock at $200, even though the stock is at 205, right? They're holding it, the person that sold you the contract, because in order to sell contracts, you can sell naked, but that's really, it's not, it's, I don't ever done that, but you hold the shares and you can sell contracts on those shares, and someone can buy that option thinking that it'll increase in price. And if it does increase over that price, you have to sell, right? And typically, this is where strategies like the wheel come in, because okay, I hold the stock for an average of 200, or I hold the stock for an average of like 180. The stock is at, I sell the $200 option. The stock is now at 205. I still made the difference of 180 to 200, right? I'm happy, but I don't get the liquid value of 200 to 205. I actually sold that in my option, right, to a guaranteed buyer at 200, right? So that's where people often refer to the wheel strategy, which is where like you would buy the call. Cool. If it goes up and the shares get called away by somebody, right? You have to give them away at the lower price. Then that's fine. You still made money. Then you sell a put, which is doing the opposite, right? And if it goes down, you just acquire the shares again, right? Automatically, and then wheel it again, rinse, repeat. That's why it's called the wheel strategy. Um, you sell covered calls on your asset. If they get called away, okay, cool, right? If they don't, you just collect the premium from the actual sell of the option, right? Because I always get the names confused, intrinsic, extrinsic value. There is value to the option, kind of like hot potato. Think of like the heat in the potato. Like you can pull out more and more heat, but the more heat you pull out, it doesn't have that direct correlation, but it's a similar kind of human concept to where, okay, like, you know, yeah, there is like extrinsic value in the difference in the underlying strike price and the asset spot price, right? That we talked about, the 200 option versus the stock is actually 205. But there is value in the actual contract itself. I can sell the contract without exercising it to somebody else, just like I were to, I can exchange myself out. I'm playing in a game of hot potato with a bunch of people. I can step out of the game and give someone else my place and sell him my spot in the game, basically. It's a bad analogy, but I'm trying my best here. So the actual contract itself has value, and so you can hold on to the contract. If you buy the $200 option, the stock is at 180, right? You actually pull out some intrinsic value in the contract as it rises from 180 to 190, and you sell early. You sell the contract early, right? You sell it early, and right, it didn't get to your $200 strike price, but it moved enough. It moved so fast and in enough time, right? That's the thing, is the time and the movement correlates. It moved so fast, it moved up from 180 to 190 in enough time to where there was intrinsic value to where you were able to sell your contract for some sort of difference and gained value. Now, that's just a different type of like trading that you can do. Some people buy options and hold them for the trading value, for exercising them, and that's their strategy. Some people buy options like me. I've never actually exercised options. I buy options when I do it to typically kind of extract out the value, as we experience momentum and volatility in the market, right? Now, think of it like that. Now, think for like an example. People like to talk about Nancy Pelosi, right? She bought NVIDIA stock options a long time ago and is still holding on to them, right? So NVIDIA, like what has split a few times. We're not going to really think about that, but let's say that she owns like the $50 option for 2028 or something like that. Well, Nvidia is at like $200 now. So someone out there sold the 2028 $50 Nvidia option at one point. Nancy Pelosi bought it. She held it all this time, and now her, to the point where she wasn't even trying to get the intrinsic value or whatever it is. She was holding it past that point, and actually her option became in the money as the strike price became, the spot price overlapped the strike price. So it became more than $50 strike price. So like the $200 stock, and she owns it at 50. She has the right to own it at $50. She can exercise those stock, and that person that owns the stock, right, that sold her the contract, has to sell her and give her those shares for $50, what they agreed on, even though it's already selling at 200. And it'll show you like a big loss. And if you like sell options on naked, right, and don't own those shares, you have to pay for those shares at those prices or whatever, and like give them to that person. And like it's like on margin and all. Like, I don't even know how all that works. That could be wrong even. Like I don't even want to get into that, but it's a really interesting financial game. Like it's very, very like engineered and manufactured in a way that is very A, enticing, and B, like very interesting, like how it all works together mathematically, how it all, like how you can, it really makes money seem very surreal, and like I don't know. Anyways, that's enough of my ramble. Hopefully that made some sense, AJ. I would highly suggest watching a short video from someone more financially inclined than I am, about it, and can better describe it. Maybe reading some passages about it, but it's very, very interesting. So appreciate you guys being here and hanging with me, and I'll see you guys in the next one.